Hello everybody, this is Keelan and Jaycee. We're here to show you our awesome hiking trail analyzer that we built with C#. The purpose of our project was to create a standalone GIS application that would allow users to import a DEM, and using that DEM analyze trails that they could either import from a previously created shapefile or that they draw within the application. And as part of the analysis, the program would show them the difficulty of the trail, along with some other statistics and the elevation profile of said trail. So here's our user interface with our map window, our legend, the output boxes for the trail statistics, and the trail graph that will show the elevation profile. We also have a number of buttons up here for the user to use. As you can see, they each have a tooltip. So it's open, save, add DEMs, trails, zooms, pan, draw their own trail, and access the help file. I'm going to hand the mic over to Jaycee now so she can start going through our code and show you how awesome this project is.
So this is our code. To start out, we establish a shell in order to use our plugins. We define the polyline and the DEM, and we only allow one DEM and one shapefile polyline at one time in our map in order to simplify our user's experience with our program. This function is just our load and initialize for our form and for our extensions. In our program, we only loaded the GDOL extension. We didn't use many of the plugins because we had already kind of done our own things and they weren't working together. So anyways, this is the code for our tool strip buttons. The first two buttons that Keelan explained are to open a project and to save a project. We open and save the projects using the app manager and opening a file dialog box where you can choose the name and the format that you save the project as. Here's some sample code. The DEM button and the add shapefile button are similar to this. We have a try and catch. Because only one DEM is allowed at a time, we remove the DEM if there's already one there. And then if the DEM is loaded, it has to be a raster layer. Otherwise, we won't load that in there. Same thing with our shapefile. It has to be a line shapefile. And we'll also remove any line shapefiles that are on our map before you add a new one. These other buttons were really simple. Just our select button, the zoom in, zoom out, and our pan button so you can move around our map. And then our user help file button. We'll have our user help file in there when we get that finished. Our draw new trail button is exciting, to say the least. When you click the button, it'll set the Boolean M digitizing to true, and it will give you a message box to tell you, just in general, how to click and make your path work along the DEM. And each of those points will be put into a list of the coordinates. As you're digitizing, every time you click a new point, the coordinates are saved as pixel coordinates, which we then convert into the projected coordinates from the DEM. Each of those projected coordinate points are added to the list of points that we've defined above, the MyDigitized points. And here we wanted to make it easier for the user to be able to see where they're clicking their points. So we save the temporary line every time it's clicked, and we add that new feature to the feature set, define the projection, save it, and then when you click a new one, we remove that old layer to keep the legend clean. We add new lines, and as you're clicking, the symbology is also made to be simple, stay the same, in black. When you double click at the end, the same thing happens. We define the coordinates of the last point, but then we end the digitizing. We add and save that final layer as our only layer because we removed all the temporary ones before, and make sure that symbology is the same as what we defined before. And then you have a new line that we can then use and run analysis on in order to figure out the statistics.
All right, thanks, Jaycee. So, as she said, once you've either digitized your own line or use the import shapefile button to import a trail that you have created somewhere else, you can then perform an analysis on the trail. And the way we do that is you click the select button that Jaycee showed earlier, and that activates, when you select a trail then in the map window, that activates this selection changed function. This is kind of a long one, so I'm going to try to make it interesting, but if you feel the need to go to the bathroom or get a drink of water, now's a good time. So first, we create some variables that this function uses. Some like these are just counting variables, creates a boolean, some other stuff like that. It also will test to see, it sets the line layer that you selected to the feature set, an I feature set, and it checks to make sure that feature set is not empty. If it's not empty, then it runs the function. And so what it first does is it checks to see if that feature set has a name defined, and if it does, it will display that in our output boxes. If there's no name, it just says not any. And then what it does is it sets the DEM to be an iRaster layer. After that, we declare a bunch of other variables here. Most of these variables are for calculations, so we have some arrays set up here for the x and y values in the lines and the calculated slope. And as you might notice, there's a couple of sets of these arrays, and this first group of variables are for the imported shapefiles. So if you import a shapefile, it performs calculations a little bit differently than if you draw your own. And so this second group of variables here is for the user-created shapefiles, and we'll explain why there's a slightly different calculation for those. Okay, so once all the variables are declared, we have an if statement, and what this does is it checks to see if this is a user-created shapefile or an imported shapefile. So if it's user-created, then what it does is it goes through the coordinates here in the line, and for each coordinate, so the first time it goes through, since the first point is not false, it skips this if statement and this do loop, and it comes down right here, and it just sets the initial x and y variables in the array, and it sets up what we call old x and old y as the current x and y coordinates. And there's no slope needed because this is the first point, so there's no slope calculated. So then it loops through, sets first point to false, and goes back up to the top of this loop. And so for every other point, what it does is it comes through, and as I said, j here is a counter variable, because what we need to do, since this is a user-defined trail, we needed to interpolate between the first and last points drawn by the user in order to get a more accurate elevation profile and more accurate statistics calculations. And so what this will do is it first figures out the interval, which we decided we wanted 100 points between the user-drawn endpoints, and it sets up some temporary x and y variables so calculations can be done. And then it enters this do loop. And what it does is it will run this do loop until j is 100, and so it should run this do loop 99 times to create the 99 points we need for 100 segments. And it calculates the distance based on the previous distance plus the calculated distance here. So we have the square root of the sum of the squares, that kind of thing. Some good old Pythagorean. And then it adds that distance to the x array, and to the y array, it figures out the elevation from the DEM. And so this x and y are going to be displayed in the graph at the bottom, and it's not to be confused with x and y coordinates on the actual map itself. Then it calculates the slope using the x and y arrays. So we have rise over run. And then it updates our temporary variables, increases our array counter, and increases our do loop counter. Once that is done, it does one final distance calculation for the actual coordinate, the final coordinate that the user selected, and it adds that to the array and comes back out of this do loop, calculates the slope for the last point, and increases the I. And so it should do that for each coordinate created by the user. Once those are created, it does some distance calculations for our output display. So it finds the actual distance, it rounds that off. It finds the elevation difference between the first and the last point, and it rounds that. It finds the maximum elevation distance, which we use in our rating system. So the highest elevation minus the lowest elevation. Finds the maximum slope, converts it to percent, and finds the average slope, and converts that to percent as well. So that's for user-defined trails. Now, if it's an imported trail, it skips that whole thing. It comes to this else statement, and it basically runs the exact same formula, except it's much simpler because no interpolation is required. Since for the imported shapefiles, there are a large number of vertices, and so we didn't need to interpolate any. And as you can see, it's essentially the same code. Calculates distance, maximum elevations, slopes, average slope, that kind of thing. Alright, so once all of the slope and elevation statistics are calculated, we could come in here and do a difficulty rating. And so we kind of decided to use 3 variables to calculate our difficulty. We wanted the total length of the trail, so the distance. We wanted the difference, the maximum elevation gain, so the difference between the lowest elevation and the highest on the trail. and we wanted the average slope to be the three things that define the difficulty of the trail. And here we just have some if statements to set the values of those difficulty ratings depending on the values of the distance, elevation, and slope. Then we added those ratings together to get a total rating and converted it to either very easy, easy, medium, difficult, or extreme. That's the rating system. That's pretty simple. Then we had to plot the elevation profile on our Z-graph, and because we had to use two different arrays for the user-drawn or the imported trails, we had to set up an if-else statement. So if it's a user-drawn trail, they're basically the exact same commands. The only difference is here on the point pairs list for the user-drawn, it pulls the user arrays, and for the imported, it pulls the imported arrays. Other than that, they're the exact same thing. It clears out the current graph, sets the variables for the new graph, and adds them to the graph, and then it sets the formatting on the graph here. It refreshes the graph to make sure it's nice and clean. And then here at the end, we show our output values. So we show the user the total distance of their trail. We show the user the elevation difference between start and end. We show the user the average slope in percent. We also show the user the maximum slope in percent, and then we tell the user how difficult the trail is. And you will see that in a minute when Jaycee runs through how the users use our program.
Okay, back to our form and our project. The first thing you do when you open up the window is you want to load a DEM. So I'll show you how to do that. Click on the button and browse to any raster file. We have all the GDAL ones in here. We have .tiffs you can use. We're going to load the Santaquin DEM, and we may have to pause it because it might take a while. Okay, so our DEM has loaded. Here it is, beautiful, and it's over here in our legend. You can see the different ranges. You can also, for all of these layers over here, we have just default GIS tools that you can use. After you have your DEM, you want to click on the Add Trail button and browse to a line shapefile. We're going to use the Manti shapefile here. And we do want it to match the map coordinate system. Here we are. These are all trails. When you click on the Select Trail, you can click on one. It will show you the elevation profile down here, and the trail name, the elevation gain. This one is going downhill from left to right. And we have the steepest slope, the average slope, the distance, and the trail rating. This one is easy. And you can click on any of these trails, and it will refresh, give you a new name, new elevation, distance, rating. Let's see if we can find some harder ones. This one's medium. It's also negative. Yeah, so it works, and it's great. Works really well. So you can zoom in on any of these trails as well. So you can click on these ones, hit the select again. You can zoom in on that. And we can zoom out and pan. Anyways, we'll zoom. Can also zoom to the layer so we can go back to the whole thing. So now I'm going to show you how we can draw our own trail. So we'll click on the Draw New Trail button, and this is our message box that comes up. Draw your own trail by clicking your intended path along the DEM, and double click to end your edits. Okay, so when we start clicking, it will erase the other shapefiles on here. There we go. So that's our first point, second point, and I'll do 3 points. So there's our drawn trail. There's our drawn trail. We can select that. Here it doesn't have a name because we created it, but we have the elevation gain, steepest slope, average slope, distance. This one is really hard. It's a difficult trail rating because it's mostly a straight line, which you normally don't hike that way. But anyways, that's what your path would be like. And this is how our program works. If you need help, you can always click on the user help file, and it is coming soon. We'll get that done. You can also save your project. You click on that. It'll save it as a .dspx file. You'll just save it into your folder, and it'll save the map and just the whole program. You can open that up again with the Open Project button. That same kind of thing. Your .dspx files.